negative 100 meters per second squared, and it's negative, indicating that it's slowing down. So, to find the force, we're going to put in mass, which is 1,200 kilograms, times 100 meters per second squared. You can drop the negative here, because force, positive or negative, is indicating a direction. We do know that this is just a decreasing symbol, so remember that negatives are telling you about directions more often, or what is happening in the object. But for a calculation of force, you don't have to have that positive or negative, unless you wanted to know the direction. So 1,200 times 100, and that's going to give you 1.2 times 10 to the 5 newton force. Okay, that's question number 1. Alright, let's see. We're going to go ahead and do question number 2. Alright, so question number 2 says that we have a 50 kilogram student, so mass is equal to 50 kilograms, who threw a 0.4 kilogram ball. So we have a second mass, which is 0.4 kilograms, and that's the ball. I'm just going to label that ball. I'm going to label this student. With a speed of 20 meters per second. So we have the initial velocity as 20 meters per second. What was the magnitude of the impulse that the student exerted on the ball? So we are looking for magnitude of impulse. So you should know that several things. Impulse is equal to force times change in time, which is also equal to your momentum, which is mass times change in velocity. And all of these equations should be on your equation sheet. I would probably highlight them in some way, since they may be asked. Okay, so the first thing is we need to pretty much determine what the overall combination of these two things are. So this isn't two separate problems. We're really looking at what the change in momentum is from the student throwing the ball, which means they're kind of interrelated in order to find that momentum. So we do have our change in momentum, which is going to be delta P, which equals mass times your final velocity, which is final velocity, and then of course we're going to find that mass times the initial velocity. So again, final minus initial, and this here is going to give you that change in momentum. So the mass that we have, final, which is the 0.4, because that's the ball being thrown, minus the final velocity, which is the 20. This should be final velocity, because this is the ball being thrown afterwards, and that's the speed that it had reached. So that's 20 meters per second. And we're going to subtract that from the initial velocity, which is the 50 kilogram student. And the initial velocity when the ball was being thrown is, of course, this shall be multiplied by, is of course 0, because it was not moving. So that means this cancels out, and I'm left with 0.4 times 20 meters per second. Okay? So once I figure that out, I now have my momentum change. Of course, remember that whatever that momentum is equal to your force times change in time, and that's equal to your impulse. So finding this change from the first object and the second object is going to give us the impulse. So 0.4 times 20, that should give you 8 so remember that this equation can be manipulative. If I have that impulse, this is the primary equation, and everything that comes off of this is going to be derived from it. So force times change of time, mass times delta V. But if I wanted to find the impulse between two objects, you just do the same thing. You're really finding the change in the entire object. So you're doing final minus initial momentums, and that's going to give you your change in momentum, which is also going to be your impulse. Okay. Next, we're just going to go down the list. We're going to do question number 3. So in the diagram, below, a 60 kilogram roller skater exerts a 10 Newton force on a 30 kilogram roller skater for 0.2 seconds. So we're just going to take down the information we have. So this is number 3. We have a mass of 60 kilograms. We have a second mass of 30 kilograms. And we have a force of 10 newtons. And we have a time of 0.2 seconds. So what is the magnitude of impulse applied to the 30 kilogram roller coaster? So remember, impulse is equal to force times change in time. So we're looking at what's being applied to the 30 kilogram person that's here. So impulse, though, is based on the two objects. So we're looking at the force that's being applied, which is given to us, which is 10 newtons. And because of Newton's third law, whatever is being applied in one direction is applied in the other direction. So that means this is 10 newtons. Times the change in time that it occurred, which was just 0.2 seconds. So we're multiplying these two. That gives us impulse, which is 2 Newton seconds. So masses were just there for information. You didn't really need them at all. So those were the distractors. Alright, question number 4 says that we have two carts that are pushed apart by an extending spring. If the average force of 1 kilogram cart is 1 Newton, what is the average force of the 2 kilogram cart? Well, it doesn't matter, right, based on size. Whatever 1 Newton force is being pushed on one object, the same as the 1 Newton force being pushed on the second object. And so they're going to be equal. Okay. Alright, question number 5. What is the speed of a 1.0 times 10 to the 3 kilogram car that has a momentum of 2 times 10 to the 4 kilogram meters per second east? So we know that, again, for question number 5, that P equals m times v, which is our momentum equals mass times velocity. So if I rearrange this, is velocity equals P divided by m. So we're looking for that speed. So we know the momentum, which is given to us as 2.0 times 10 to the 4. And we also know what the mass is, which is given to us as 1.0 times 10 to the 3 kilograms. So velocity equals 2 times 10 to the first meters per second. So that's number 2. Question number 6. We have a 70 kilogram hockey player that is skating east on an ice rink. Is hit by a 0.1 kilogram hockey puck moving toward the west. The puck exerts a 50 Newton force toward the west on the player. Determine the magnitude of the force of the player exerts on the puck during the collision. And that just is going to be conserved, right? If that's applying 50 newtons, then the other player applies 50 newtons. So a lot of third law questioning here as well. Number 8, which situation will produce the greatest change of momentum for a 1 kilogram cart? So if you just calculate mass times velocity for each of the momentums and provided with that one mass, you'll determine that the greatest amount of momentum being provided is number 3 option, applying a net force of 5 newtons for 2 seconds. For number 9, a 0.149 kilogram basketball by a baseball glove on a catcher's hand, the magnitude of the average force exerted on the ball by the glove is. So we are looking for the force that's being applied. So that means we're using our equation F times delta T, which equals m times v. We know that the mass is 0.149. We know the velocity is 15 meters per second. We also know that the time that it occurred was 0.04 seconds. So we're looking for the force. So we're going to divide each side by 0.04. And force is equal to 0.149 times 15 divided by 0.04, and you should get